If I asked you what's the difference between this Amiga 2000 board and this A500 board, well, you might point to these expansion slots. 5 ZORRO 2 slots, coprocessor slot, video slot, and even some ISA slots. But it's these ones that I want to pay attention to today. The ZORRO slots and that coprocessor. Now, we all know you can add either of those to the side of an A500. You can use this little board to give you your coprocessor, or you can use this board developed by Matthias Hendricks back in 2015. That gives you one ZORRO 2 slot. But it does have that limitation, even says it on the card there. Only use one DMA card. You can only have one ZORRO 2. There are loads of different ZORRO 2 cards though. I have a wide selection of them myself. Everything from RAM cards to sound cards, even a network card as well. But why can't you use multiple cards on the side of an A500? Well, that comes down to one other difference between these two machines, and that is this chip. That is Bluster. He's responsible for managing these 5 ZORRO slots. So over the last year or so, I've been working on a little expansion for the side of the A500 to try and duplicate this functionality from the 2000. And I've come up with this Deigo 500. This will give you those 5 ZORRO slots. It gives you the coprocessor slot, and it's all controlled by an onboard Bluster. There is quite a bit of building involved in this, so we're going to put it together today and give it a test. But before we do that, let's take a quick look at the schematics, and I'll try to explain how it works. So this project was drawn up using KiCad version 8. Yes, I know version 9's out now, but as I say, I've been working on this for a while. And it's based on the Amiga 2000 Rev 6, but also the EINT 2000 schematics by Jason Spear. As you can see here, there are a couple of boards associated with this project. I'll get to that in a minute, but let's just first of all take a look at the main board schematics. And since this is one of the first projects I have put together and drawn up, please excuse the messiness of these schematics. I'm sure it doesn't conform to any industry standards, but we've got our A500 sidecar, the data and address buffers. There's another buffer chip in there as well, handling a few other bits. The A2000 coprocessor slot, which, yes, I know actually sits before those buffers and everything else. That's it there. That's the bank of buffers. So on the schematic, I do need to move that sort of into here. But just through the development of this board, the coprocessor was added in sort of last minute. So that's why it's hanging out here. I will redraw this at some point so it does make more sense. We then have Bluster, or Bluster, as I've written there. I'll come back to that. But then it's just power, reset. There are a few remote signals that we need to pick up because unfortunately not everything is on the A500 sidecar. And then it's just the 5 ZORRO slots themselves, all the termination associated with that and the auto config chain. But the thing that makes this work really is Bluster. Now, Bluster itself is a modern recreation of that original Bluster chip made by Liv2. And in fact, we built one of those for my EINT 2000 at the time. I didn't have an original chip. Although for us, this is a custom version of the CPLD code because one of the problems that we faced was that 3 of the clock signals that we needed to run Bluster, when they appear on the A500 sidecar, they are unfortunately inverted. That was CDAC, CCK and CCKQ. So as I have them drawn there is as they are presented on the side of the 500, CCK and CCKQ being active low, CDAC being active high. We actually needed them the other way around. So rather than introduce more logic to invert those again, potentially further delaying those clocks, throwing them more out of phase, Liv2 was able just to modify the code for us to handle those inverted clocks. Now that in itself does present one slight area of concern for me with those clocks being inverted inside the 500 before they come to the sidecar slot, well, that in itself is adding a little bit of delay to them. It is throwing them slightly out of phase. Now it is very minor. We're talking about what, 10 nanoseconds, something like that. So I'm not really sure in terms of the A500's timings if that will create any problems. But how does it work? Well, it all relies on Bluster. And I'm pretty sure that Bluster itself actually stands for bus master, because that's what this chip does. It controls which device masters the bus. Now the 68000 has various lines attached to that. To achieve that, it's got bus request, bus grant, and bus acknowledge. So let's say, for example, a ZORRO card in slot 3 there, it wanted to take over the bus. So EBR3, or expansion bus request 3, it makes a request through Bluster, which goes through the bus request line of the 68000. That is then granted back to Bluster, back through signal expansion bus grant 3 to the ZORRO card, which then itself asserts bus grant acknowledge back to the CPU directly, which tri-states the CPU, allowing whatever card is in there to take over. It's more or less the same thing for a CPU card in the coprocessor slot, although this time the signals between that slot and Bluster, they're called CBR and CBG. Coprocessor bus request, coprocessor bus grant. But this is where things get slightly more complicated, and please bear with me here. I know I'm not very good at explaining these things, but if we look over here on the schematics, remote signals, that's because there are several things that just aren't present on this sidecar. One of them is associated with that whole bus mastering side of things, and that's the first signal there labeled bus. Now, originally I thought bus was associated with the ZORRO side of things, but it's not. Bus is only driven by the coprocessor slot. In fact, it's driven by whatever you would plug in there. So if you put your, I don't know, A2630 accelerator card into that coprocessor slot, it will do the negotiation through Bluster, just like we explained, but then it will assert bus. And that's so it can tri-state the CPU inside the Amiga, basically disconnecting it from the bus permanently so that the CPU card can take over. But the rest of the bus mastering can still continue to happen, just like it always would, although this time it's only between the ZORRO slots and the coprocessor slot via Bluster. That bus signal does also come to Bluster, or to Bluster, sorry, but I think that's just so this chip knows that the onboard CPU has been taken off the bus and all other requests and grants and whatnot go between the ZORRO slots and the coprocessor. Just in the middle of editing this, just cutting in here because it seems what I just said there may not be correct, although I'm not 100% sure, so if anyone does know, maybe let me know. But it may be the case that the bus signal from your CPU card, it's just always tied to ground when that CPU card is installed. Try stating the onboard 68K without any negotiation going on there. In fact, I actually do that myself later in this video to try and prove that the bus board that we built works. That board which I'm just about to tell you about now. Now, obviously, the logic to drive that bus signal at the CPU, it's just not there inside an A500. Why would it be? There's no coprocessor slot in an A500. So, if you go into our JLC box here, well, that's where these two additional boards come in, or well, this one anyway. This one I have dubbed the bus board. This will sit in line with the internal CPU. Your bus connection needs to be wired from there to there. There's a 7408 to fit, and that reintroduces that bit of missing logic. Of course, the other solution to it is just remove the internal CPU, but I wanted to provide this option for, this functionality here, just to try and make the thing complete. And just while we're talking about the coprocessor slot, one of the other remote signals that we need to pick up is on pin 7, that is the 28 MHz clock from Agnes. Now, I know it's not great running a clock signal through a wire like that. It can be subject to interference, but I don't really see any other way of doing it. The only clock signal that's on the A500 sidecar is the 7 MHz clock. We are picking that up here, but that 28 MHz clock just isn't there. Now, to be truthful, I'm not 100% sure how many accelerator cards actually need that 28 MHz signal. The aforementioned A2630, well, it doesn't seem to use it. I mean, Jason Spear recreated that card along with recreating the A2000 in the EATX form factor, and I've checked the schematics for it, and it's not using that 28 MHz signal for anything. So it may not be a problem, but I'm leaving the point there that it can be injected should you have some accelerator card that, for whatever reason, does make use of that signal. But there are a few other remote signals there. There's the extended interrupt stuff and a configuration link as well, which I've labelled there as CRG 500. The auto config chain on the Zorro side of things is beautifully simple. It really is. Every card presents its auto config information to the Amiga at the same address space, but it's all handled by a 7432. Essentially, the input gets pulled low, the config in, that is. Your first card will see that. Its config out will be held high until it's done its negotiation with the Amiga. Once it's done that, that config out goes low, driving the next config in low. And it just continues like that. But if you had, say, one of Live2's gotta go fast RAM adapters in your A500 underneath the CPU, well, you would need to connect its config out to that config in. Or indeed, if you had anything in that CPU socket on the Amiga, be it the RAM expansion, one of the accelerators, say for example that Spitfire that we built a while back here on the channel, it's got a config out, you would need to connect that to that in to allow the rest of these devices, whatever you may have in these slots, to be configured. So again, only necessary if you need it, but it's there. And then it's just the extended interrupt stuff. Now, I'll be honest with you, I'm not actually sure what uses the extended interrupt feature of the Zorro 2 slots. But certainly everything that I've tested so far doesn't seem to need it. It might only be bridge boards, but I'm not sure about that. If anyone knows, maybe let me know. Much like that boss signal though, the logic to integrate the extended interrupts, well, that's also not present inside an A500. So that's where this other daughter card comes in. This will sit in line with Paula, because the extended interrupt lines, well, they seem to get muxed in along with the IPL lines in the Amiga, which are generated by Paula. So I think that's the best place to put this. In theory, we could possibly do it at the CPU, or we could even do it out here if we forced people to always use this coprocessor slot. But I didn't want to do that. I wanted to leave this as open as possible to different configurations. So if you've got something that needs the extended interrupts, this has to go underneath Paula, and you need to run 4 wires from there to there. So the last thing then I just want to talk about briefly on this is its power. And as you can see, as per this older revision of the board, we have a 24-pin ATX power connector on it, and we've got a 4-pin pass-through. See, the original power bricks that came with your Amiga 500, they're just not going to be up to the job of powering 5 Zorro slots and a coprocessor slot hanging out the side of your A500. In fact, a lot of the A500 expansions, they all came with their own power supply. And while yes, I probably could have made this, that you're just having a second power supply for this board, I thought, would it not be easier just to have one power supply connected to this big enough to run everything? This pass through then, you plug a cable in there, connect that onto the back of the A500 where the original power brick went, and that just runs everything. There's a switch at that point. Granted, it's just a latching power switch at the minute, but that's what will turn the system on. But that's also why we have this warning on the Deigo here. This board powers your A500. Do not use with original power brick. If you did try to use this in combination with the original power brick, well, the likelihood is that it just won't work. Worst case scenario, smoke will escape from something. If you just try to use this on the side of the A500 with the original power brick and no ATX, it definitely won't work, because we need the 3.3 volts from that to power the CPLD. So that's the only stipulation I am making with my board here. You must power it using an ATX power supply. Even a Pico ATX power supply should be enough. And you must run a wire from there to the back of the A500. Now the power rails are connected at the edge slot. And I'll be honest with you, testing with this one, it does work if you just plug that in with the ATX without the loopback cable. But those traces on the A500 side are rather skinny. And if you had a lot of other accessories inside your 500, well, I wouldn't like to rely on those thin traces. That's why the loopback cable, or the point for it there, is included. But yeah, that's pretty much how this works. So how about we try and put this one together to test it. Now you've seen me build plenty of boards before, so we're just going to skim through this. But since this is the first time that this has ever been built, I'm going to start with all the power stuff. We'll do the ATX connector, the pass-through, all the caps associated with the power rails. There is a voltage regulator there, -5 volt reg, and that's giving us the -5 volt needed for the ZORRO slots. But we'll put all that on first of all, and then we'll power this up, standalone, just as it is, and just check that all the voltages are where they're meant to be. I'm sure it'll be fine, but I just don't want anything turned into smoke. All the components are labelled. I tried to label everything with what the component is in terms of its component number, but also the resistance or the capacitance of, whatever said thing is. All of those values I have stuck underneath the component just to try and keep the board as tidy as possible. And the other thing that I've done is just try to keep all the capacitors in the same orientation as far as is possible. All of these electrolytics are all facing so that the positive side is towards the bottom of the board, although these ones, the positive side is to that end of the board. Oh, and there's one of our first problems. That doesn't fit that footprint. I mean, the footprint of the package is correct, but it's the position of the 4 pins is not correct. Nope, that's a problem. Right, we'll leave that for now. Okay, let's try and put some power through this. And we'll just measure a few voltages before we do anything else. Right. ATX power supply. I've got an old hard drive here just for a bit of load. And if I switch on the power supply, it currently shouldn't do anything because that power switch there is open. Yep, that seems right. So we'll just switch off the power supply again. And we'll close this. See, now we flicker of the LED there. It's probably just whatever residual power was within the caps in that PSU. Well, let's go ahead and power this on now. Our LED came up. So let's just quickly test some voltages across this board. Starting up here at that pass-through power connector. So ground is there as labelled. Just beside ground is -12. And yeah, that's right. And above ground is +12, also right, and then 5 volt. Yeah, that's fine. Now we should have 5 volt here on the coprocessor slot, which we do on those 2 pins. Should be the same there, just across the ZORRO slots. Yeah, that's all good. There's 12 volt on the ZORRO slots. -5, that's fine, being generated by our -5 volt regulator here from the -12 volt line. That all looks good. And there's -12 volts on the ZORRO slots as well. That all looks good. Do we have 3.3 volt down at the CPLD? Now I'll not measure it on the CPLD itself, just because there's a ground and a 3.3 volt right beside each other on this, and I don't want to short anything. Instead though, we can measure it here just on the JTAG. And yeah, 3.38, but that's alright. So I think we're pretty happy there We seem to have our voltages all more or less where they're meant to be. Although I have just noticed a problem on this board, so we are definitely going after another revision. It's very minor, but where I've wrote 7 MHz beside that pod, that's wrong. It's actually that pod there, which carries 7 MHz. But I put the trace from that down sort of that way. And I put the 7 MHz label beside the trace. I need to move that up to there, so that's more obvious where that 7 MHz needs to come from. That's because, as you can see here, A500 edge connector. Make sure 7 MHz is connected on A500 side. JP6 may need to be closed. Well, yes, that's correct, but only on a Rev 6 Amiga 500. If you've got Rev 8, as in a 500 plus, you don't need to do anything. 7 MHz is always connected. But if you've got a Rev 5, or maybe even a Rev 3, there is no 7 MHz connection at all to the sidecar slot, so you will have to run a wire. So I'll need to rewrite that just so it does make more sense. But next thing I think we'll do then is we'll fit Bluster, fit the CPLD, and we'll get it programmed using a Raspberry Pi. Everything's hooked up, ready to program. Just using the Pi and Liv2's guide for using said thing to program these chips. We're connected to it over SSH here on a command prompt. That's the command that we need. So if I hit enter, it seems to be programming okay. And I think that's it. Just really a lot of assembly to do now. That's the bank of buffers there, the 245s. This O8 here, that's handling the reset signals for this board. And this 3.2 is doing some of the other logic just associated with Bluster and the ZORRO slots. This 3.2 up here, that's handling all the auto config stuff. But let's get it built so that we can get it tested. Finish off the top side first. Okay, that's Deigo built along with the 2 daughter cards, but before we plug any of it into the 500, or well, this is a 500 plus that we're going to use here. Before we plug it into that, I just want to check those voltage rails again. That's 5 volt, that's fine. 12 volt, looking good. Negative 12, that looks good. And there's our negative 5 volt rail. So that all seems to be good. What about the 3.3? Yeah, that's still there. So let's try it on the Amiga. Now I'm not using that cable to the back of the machine, not connecting the power that way yet. As I said, power is connected at the edge connector here. But to try and take some of the strain off those quite small traces, you know, on the 500 at this side, you can see the floppy drive. I have it powered directly off the ATX brick. There's nothing else really in here, just a bog basic 500 plus, but with an extra 512k of chip in the trapdoor. So let's see if it works. Let's see if it comes up. Let's just see what happens. Yep, 500 is starting. Okay. That seems to be good. So how about we add a ZORRO card? Now I don't have a wide selection of these, but I was going to use these two today. Gotta go fast RAM 2000, that's 8 meg of fast RAM. Sits on the ZORRO 2 bus, so perfect for this. And this AT bus clone with a CF card there and a basic installation of 3.1 on that. We'll just go with the memory expansion first. Now when you're inserting cards into Deigo here, They go in as if this was an Amiga 2000. So treat the front as the front of the machine. Most of these cards will have some sort of labelling on them to denote which way around they go. This one says front that way, so it goes like that. The other thing to remember is that the component side of your cards face the 500. And I suppose we'll just go with the first ZORRO slot there. So if I powered up this time while holding the two mouse buttons, that should get us into the early boot menu. And if we go to expansion board diagnostic, that should list any of the expansion boards. It should list this. Yep, there it is. And status is working. Fantastic. So let's boot to Amiga Test Kit and let's take a look in memory. Again, that is confirming our 8 meg of fast. How about we just run a memory test on that? I'll just let this go around a couple of times just because it does take a while. Okay, it's been around 3 times there. It seems happy enough, but I will give it a more thorough test later. But this is also a good test of our Bluster implementation. Because what it's doing at the minute, right? The CPU there is filling that RAM, and then it's reading that back. Now, the data bus between there and there is buffered by these things, these 245s. And the direction pin on that, as in what controls the direction of the data flow, it is controlled by Bluster. So if we wait here until it's doing a fill, so the CPU is writing to the RAM, there we are, so it's filling, and if I go onto the direction pin there, you can see that that is high. And then what it's going to do is checking now, that's changing to a pulsing signal. That's the CPU reading back out from that RAM, and that's being controlled by Bluster. So hopefully that goes some way to prove that, you know, this is working, or appears to be working anyway. So how about we give it something else to do? Let's put in this card as well. Now, I'll stick that, I don't know, we'll put that into the third slot, and I was very nearly putting it in the wrong way around there. So that's in ZORRO slot 3, and as I say, it's got that CF card in it with an installation of Workbench 3.1. We'll not bother with the 2 daughter cards yet. Let's just see what this does. Absolute nothing. Oh dear. So let's just power cycle. And we'll try that early boot menu again. It's seeing that card, but it's not seeing that one. This card just has the solder finish, so sometimes you get a odd connection on that. But nothing a squirt of contact cleaner shouldn't fix. Yep, we now have 2 boards. So let's just continue to boot. There is an activity LED on that, which I can't really see. But is it booting? Yeah. We have Workbench. So the ZORRO side of this seems to be good. We'll give it a more thorough test later. For now though, let's try and run something off that CF card, will we? Road Avenger is in here. Purposely put that on there because it hits the drive quite hard, you know, loading all the videos. But does seem to be working fine. So at least you know the ZORRO side of this revision on the board still works. What about the CPU slot? What an absolute faff trying to get that CPU into those holes. But it's there now, and then this goes in here. Now the CPU is purposely offset just that little bit there to allow the keyboard to still fit, I think. Yeah, no. So that board will need further revision. That needs to go further back. Because at the minute it is still hitting off the keyboard just at that front edge. My original intention for this actually was to make it one of those L-shaped things, so that you could use one of the accelerators in here as well. I might just revisit that idea. But for now, we're not worried about it. I don't need the keyboard just for this testing. And just looking at this actually, the other thing that I might do is move that point for the boss signal connection to the other end. Just because here it is a bit close to that capacitor, isn't it? Ultimately, when you're fitting this in your case, you'll need to run that wire, through there underneath. But for now, since we don't have the lid, I'll just attach that on the top side. And then for the coprocessor itself, well, let's just use another 68K because that's all I've got. Although we will be modifying this one ever so slightly, or you can see it's modified, as it has this jumper block on it. That which I need to open. See, that's sitting on the E clock signal. And while this setup with boss being asserted here, boss will be asserted low by this thing, just that wire there, ties boss to ground. But with boss low, this CPU is tri-stated. Mostly, it's still generating an E clock. Now the E clock is used to synchronize various components in the system, but because this is also a 68K, this will be trying to generate its own E clock as well. So the appropriate pin there has just been cut. That jumper block has been put in place so I can stop this thing generating an E clock, or stop its generated E clock from getting into the Amiga. Right, does this work? Oh dear, first problem. Let's just remove this altogether. So let's just solely rely on this CPU. I will need to put that jumper back on there so this thing is again generating an E clock for the system. Let's see if that works now. But no, that still doesn't seem to be starting. And yes, I do have this in the correct way around. Component side this time is facing out of the case. Alright, I think I figured it out. Doing a bit of testing here, and don't ask me how, but it seems I've got two of the pins reversed. Address lines A21 and 22. Plugged in this CPU breakout board. Remember I showed you this in the intro to the video. That is just essentially another one of those. But it is just straight through all that. So everything should more or less line up. There are a couple of signals that are slightly different. Just because this is a more true implementation of an A2000 CPU slot, some of the signals are routed through Bluster. But you can see if we work our way up this, more or less everything lines up. But that is until we get to that point, where instead of making connectivity on the right hand side of our socket there, it's making connectivity on the left hand side. And equally, if I move this one across to the left hand side and this one across to the right, that's our problem. So yeah, bit of a problem, but hopefully easy fixed. All we need to do is lift the associated pin there and there and just run a wire between them. Okay, this is the wires made off, swapping those pins around. And we'll just stick this thing in here, just to see if it boots. Yep, there it goes. Kickstart came up, it's now working. So hopefully that's all it was. How about we put our ZORRO cards back in, and we'll stick the boss board back in as well. Okay, everything reconnected, but I'll need to remove that E clock jumper from this CPU, and hopefully this boots. Yep, does seem to be. Although it's not seeing the hard drive again. Unfortunately, that card has been in and out of slots so many times that the edge connector on it is just starting to go. Just because it is lead coated, as I said, there's some quite deep scrapes in it now, just from that being in and out of these slots. Although I think it is booting this time. Yeah, there we are. Perfect. So it's booting to that CPU. That CPU should be tri-stated, although it is still generating its E-clock. And in fact, we can prove that. So with BOS being asserted low to this CPU, what that does is pull the bus grant acknowledge line on that chip low. That is on pin 12. So let's just check. Oh, I just managed to crash the system. But there it is there. Bus grant acknowledge, that is sitting low. Although this chip is still generating the E-clock for the system. That is on pin 20. And that's it there. It is quite a slow clock, only 700 kilohertz, but that's correct. I think it's 1/10 of the overall system clock. If we were to power this off, and if I put that jumper on there, then that CPU will still be tri-stated, but both of them are generating E-clocks. That will clash, and it shouldn't boot. I know, it's just sitting there at a black screen. I think that proves that our BOS board works okay. Now, if you were using a true Amiga 2000 accelerator in here, those things don't try to generate their own E-clock anyway. They'll just take that clock from this chip, synchronized to that. But as I say, that's the only thing I have that will fit into an A2000 co-processor slot or CPU slot. The last of our boards then, the Paula board, or the extended interrupt Paula board, that is going to go in there. Unfortunately though, I've no means of testing that because I've nothing that is going to use those extended interrupts. System still should work okay, and it shouldn't have any impact on the Amiga generating sound, so we can test that. Let's go into a demo this time. I just have the one in here. But there it is, it's working away and it sounds correct. To finish off the day, I thought we'd try something. You see, it might be argued that the Deigo 500 here, the purpose of that is to try and turn your Amiga 500 into an A2000. So why don't we do that? I've stripped all the boards out of my A2000, put them into Deigo here. So we've got the Pi Storm, we've got the SID card, the Prelude Sound card, and the ZORRO LAN IDE card. Let's see if this works. That's even my hard drive out of my 2000. So this should just boot as if it was my 2000. And there we are. We're in Workbench 3.9 with a nice clear high resolution screen over RTG from the Pi Storm. Please ignore the rolling image on the LCD. There's very little I can do about that. It's just this camera. So let's give it something to do. Now the LAN card should be online. If we load up iBrowse here, and in fact while we're doing this, let's also give the Prelude something to do. Let's run an MP3 through Amiga Amp. Now the reason that I'm particularly keen to test the Prelude here is that I think this card does DMA. In fact, it might only be the only card I have that actually does DMA, so the only one that actually is becoming a bus master. And I think it will be doing that while trying to play an MP3. Now I'm not 100% sure, so if anyone does know better, please let me know. But let's just try it anyway. Well, it's playing that happily enough. Let's go to AmiNet and see what's available. Latest packages. What's this one? Ami Arcadia? Some sort of emulator for the Amiga? Let's download that. And we'll stick it onto the RAM disk. But yeah, it certainly seems happy enough doing this. Playing an MP3, downloading files from Amiga and sticking them onto the RAM disk, which will be the memory on the Pi Storm. There we are, downloaded that fine. But there are other things we can do as well. How about some of those RTG games over here? How about a bit of Amiduke? Another good one to test actually, since it will be using the prelude again for AHI sound. But if I also just leave this intro and demo looping, well, it will occasionally anyway be accessing off the drive here. Just every time it goes to load or reload the demo. And yeah, it seems happy enough, doesn't it? This is a very quick test though, but like I say, this is actually quite a good thing to leave running. So I think I'll maybe just do that while I go and do a bit of editing. Leave this running for, say, an hour, just to see if it's stable or if any issues crop up. Well, I got fed up listening to the Duke Nukem music, so switched it over to Quake 2 instead. RTG version again, using AHI sound again. It's been running this for, I don't know, half an hour or so in the background. And yeah, it is rock solid. Everything here just seems to be working. Well, that's the Deigo 500. Must say I'm pretty pleased with how this has turned out. The board works. We've got our A2000 CPU slot and 5 ZORRO 2 slots. Just needs a couple of minor revisions. We need to sort out those two address lines that were mixed up, and I want to alter some of the text on this. The other thing I might do is change the footprint on the ATX here and the pass-through, and rather than having them vertical, I might make them horizontal, so that you'll be connecting cables in, you know, like that. Just means that nothing then would potentially get in the way of, say, a full-size CPU card. Here's a question though, what are we going to put this in? Because I suppose it does need a case. And the Prelude here, it raises a good point, doesn't it? Because that's a full-length ZORRO 2 card, and that thing is massive. So if we had a case that was going to house 5 full-length ZORRO 2 cards, it's going to be massive sitting on the side of your A500. I'll be honest with you, I'm not really sure how to address that. I'm leaning towards maybe like an open frame case, just something to hold Deigo and hold the ZORRO cards. Although that does leave it open to the elements, you might say. Leaves it open to getting a knock or, you know, spillages or anything like that. So I don't know. I think in the first instance, some sort of open frame case would probably be the way that we do go here. And indeed, the other thing that I'd like to get some feedback on is this potential pass-through power connector to the back of the A500. Throughout all our testing today, I haven't used that. I've just powered the 500 from the sidecar. Although in terms of longevity, I'm not sure how good an idea that is. Those traces in the 500, in particular the 5V rail, I'm not too worried about 12V or the negative 12V. But that 5V rail is the same size as the others. It looks to be about 1.5mm wide. And I'm just not sure if that could carry enough current to run the A500 without any issues. So if anyone is perhaps more experienced in PCB design, I would love to get your thoughts on that. And indeed your thoughts on anything else that you've seen throughout this build in terms of the board's layout or in terms of the schematics that you've seen there. But that's going to be it for now. So hopefully you did enjoy this video. There will be plenty more Deigo stuff coming in the near future here on CRG and on a couple of other channels, because Gadget UK and Andy from Hack Build Restore, they're going to get one of these boards each to build and do a bit of testing with. They've promised to test them with their range of ZORRO cards. Hopefully they'll have a few other bits and pieces that I don't have here, just to make sure that our Deigo is working properly. But that's going to be it for now. Thanks for watching, and I'll see you next time.